web page looks same, but the IP address is different. You're going to a wrong place. So this is why actually these sort of issues are very serious, especially in terms of security. Cache poisoning, phishing attacks, and things like that are very common nowadays. Then there are lots of other security issues in terms of impersonations, DNS hijacking, right? So these things can happen. Even these authoritative servers, say for example, sometimes for better redundancy, we try to have multiple authoritative servers because in case if one server goes down, you have to have some redundancy. So you would try to have multiple authoritative servers so that in case if one server goes down, your whole domain will not go down, because otherwise if you only have one server, if that server goes down, if someone attacks that server, no one can get to your website, no one can send emails to you, and so on, right? So that's a big issue. So that is why we have to make sure that we have redundancy over there. So there are lots of issues to be considered, especially from a security point of view, and also impersonation should not happen as well. Because if these authoritative servers talk to each other, we have to make sure that they trust each other as well. If one authoritative server is talking to its other authoritative server, they have to have synchronization, they should be synchronized, they should be trusting each other, and so on. So there's a fair bit of security should be put into those contexts as well. So the whole idea what I want to give you here is that DNS is not secure until you secure it properly, right? If you just configure DNS, operationally it might work, the DNS queries might work properly. If you ask questions from DNS, you will get the answers, but as far as security is not there, it's not secure. So it is very important for us to spend time and try to actually consider these concepts and try to protect your DNS infrastructure. So I just want to actually highlight one of the key mechanisms that we use in this regard, which is what we call DNSSEC. So DNSSEC stands for DNS Security Extensions, right? That's the acronym for that, DNSSEC. Now, with DNSSEC, what we are trying to do is we are trying to protect our DNS data, because our DNS data lives inside our DNS databases or inside DNS servers basically. And also it lives inside those caching servers or resolvers that we discussed before, the recursive servers. So when we have DNS data in those places, in case if someone managed to change these data or pollute or poison this DNS data, we should be able to detect. So that is where DNSSEC actually will help you in. So this is why DNSSEC is an important security mechanism for us to consider in terms of protecting DNS data. If we can protect that, we can avoid those cache poisoning issues. If we can protect, if we can implement DNSSEC, we can protect those DNS hijacking issues and so on. So it is a very important security mechanism. Now the whole concept behind DNSSEC is, what we do is we digitally sign our DNS data. So you keep DNS data in all those DNS servers, right, in your databases. And what we do is we digitally sign those data. Probably you know about these cryptography, right? So in cryptography we use things like asymmetric keys, private keys and public keys. So what we try to do here is that we generate those keys, private keys and public keys, and we sign our zone data or the DNS data. And then we generate signatures, that is associated with this DNS data. And those signatures can be verified using our public keys. So that's the main concept behind DNSSEC mechanism or the technology. Now, say for example in this case, if example.com want to protect its own zone or its own database or the DNS data, it can sign this example.com zone file, and then propagate that trust, right? It is very important about the trust propagation, because because always DNS is a hierarchical database. So what we do is then we propagate that trust to the upper level or the parent level. As we saw in the DNS hierarchy, we have the root, the TLDs, the next level domains, and so on. So if the second level domains has digitally signed its DNS data, it should always propagate that trust. In other words, the public keys or the hashes of those public keys to its parent zone, right? So in this example, example.com would propagate that trust to .com, and in the same way, .com would then sign its zone, the .com zone, and then propagate the trust to the root zone. Right? So that's how the trust would all the way go and end up in the root zone. So then, when the recursive service, when it does queries, right, recursive service stays in the middle, and when it does all the DNS queries, now it can validate whether we are getting the responses from the right party, the right servers, and also it can validate those signatures. So this will help us to achieve two important security principles. One is the authenticity, right? Authenticity. That means, are we talking to the right party? Are we getting this information from the right place? And the other thing is integrity. Integrity means the data has not been tampered or changed. So this is where also, like in security, when we download software and so on, we check the checksums, right? So the same thing, to make sure the integrity is intact, it is there, right? So the same sort of principle here, by using those signatures, and we can make sure that the data has not been modified. So that is the basic concept behind DNSSEC. So if I just try to compare without DNSSEC and with DNSSEC, so on your left-hand side, you will see without DNSSEC. If a client is sending, okay, I want to visit my bank or myexamplebank.com, right? But always, there could be an attacker who could try to poison the caches or send some bogus responses to a recursive mail server, and then the client would get that wrong IP address, which is shown in the orange color over there in the left side. So the client will get a wrong IP address, which means the client will visit the wrong website. So this could be basically a phishing site. So client would get to a wrong bank website instead of the correct bank website. But if on your right side, if you have deployed DNSSEC, and if we can validate that whole chain, the hierarchy, the DNS hierarchical model, we can stop this thing. We can drop that query in the first place. When as soon as the recursive server gets the wrong response, it will drop that response. It will not give that response to a client. So in this way, the client will not get a wrong IP address. So this is just to get a comparison. If you deploy DNSSEC and if you do not deploy DNSSEC, what sort of difference that will get to the end user. Now, I also want to actually, before I finish my talk, just want to actually give you some statistics. These are all real statistics, right? So that you get a feel of what's happening there in the world in terms of DNSSEC deployment, so that you can also think about this to deploy in your networks. Now, globally, currently I told you that we have around 1,500 top-level domains. To be exact, around 1,543 top-level domains exist now, right? So this means like .coms, .net, .edu, .np, including everything, right? So the top-level domains, we have around 1,543. So out of that, 1,399 top-level domains, they have deployed DNSSEC, which means they have signed their top-level domain zones, right? 1,399 out of 1,543. So one thing to note, actually, specifically from Nepal's point of view, is .np is actually not within that 1,399. So this is something for you to consider actually in Nepal, right? So that means actually .np zone, .np domain has not been signed. So this is something that I think as a community in Nepal that you can possibly look into. So the top level domain can be protected, right? And then, so currently around 90% of those TLDs, they have deployed DNSSEC and they have protected their zones. Going to the second level domain, currently about 4% of second level domains have deployed, not much comparing to that 90%. Second level domains is only about 4%, but 4% if you take as numbers, it is still very large because currently there are worldwide, currently there are like 400 million domains, second level domains. So if you take like 4% of like 400 million, still that's a big number. But if you still have second level domains, if you can deploy, we can bring those numbers even more than 4% of course. So this is again something for corporates to think about, for any second level domains to think about. So some statistically about countries, the CCTLDs that have deployed DNSSEC here. So these are different stages. You can see that worldwide, of course, the orange shows the experimental stages. The yellow ones, they are sort of, they are announcing that they are going to deploy. And there are some partial deployments at the current. Now, the light green shows that the trust has been sent to the root. So the root zone, the root servers, they have received the trust from the top level domain. But the TLDs, those TLDs, they are not still accepting the trust from their second level domains. The last one, which is the dark green, that's all the production. They are everything, those